Air contains mostly oxygen and nitrogen. At a given temperature, what is the ratio of the average speed of a nitrogen molecule to an oxygen molecule? So this is kind of an interesting question. I don't know if you ever like stay awake at night wondering, like, I wonder how much faster the nitrogen molecules are going than the oxygen molecules. Well, if you have done that, then here's your answer, hopefully. You probably haven't, right? The formula we have is the RMS formula, which I'm going to use to answer this question. So whether we use I'm just going to write down the molar version of it, 3RT over M. But I think the thing to notice about this is that if we're talking about a given constant temperature, this implies that the speed, or maybe the RMS speed, is proportional to 1 over the square root of the mass. And that's really true regardless of whether you're taking the molecular or the molar perspective on this. And so if I want to know, like, what is the ratio of the average speed, it said average there, which is actually not RMS, but it turns out it'll still work because the expression for the mean speed as opposed to the RMS is similar to this. It just has some different numbers here. It still has the RT over M and it's under a square root. So this relationship winds up holding for it. In this case, since the atomic mass number of nitrogen is 14 and of oxygen is 16, I think all I have to do to calculate that ratio is take the square root of the ratio of those masses. And we're being asked for the ratio of the speed of nitrogen to oxygen, which nitrogen being lighter should actually be going a little bit faster on average. And so I want to take the square root of 16 over 14. One could argue, well, wait a minute, aren't these diatomic molecules? Both of them are, so maybe the ratio should have been 32 to 28, but that reduces to 16 to 14, which actually reduces to 8 to 7. But whatever way it works, I can put that into my calculator, and then my calculator says like 1.069044968, but I don't know if I need all that. So I'll say 1.069. Maybe that's more than I need, right? I mean, what are the sig figs on this question? It's not really super clear. Well, the answer says 1.07. I think we can agree that even though the rounding's different, those are in agreement there.